A quick note on these next two sections. They'll be discussing Spark's background, past and present, and aren't necessary to learn the framework. If this is not of interest to you, then you can head directly over to the installation section. Now, we've seen how Spark shrinks processing time, machine resources, and code when compared to Hadoop. But there's one other problem that it solves: the MapReduce Explosion. The explanation for what this is comes from Jon Stoica, Executive Chairman of Databricks, the company commercializing Spark, which we'll discuss further in the next section. He talked about how the first cell phones were clunky and led to a wide array of specialized gadgetry, similar and complementary. But then the smartphone came along and united all of that chaos into one easy-to-use device. So, in the same vein, we know that the original big data processing problems were alleviated by the advent of Hadoop. And in the early years, it was a big leap in technology. However, I think Tim Tolley of Yahoo put it best when he said that MapReduce is like pushing a square peg through a round hole, meaning that it's very restrictive in its design as it has a very narrow focus specifically on batch processing. This overspecification led to an explosion of specialized libraries, each adding a new API to juggle in your big data mental model, each attempting to solve different problems. So, say you want to process streaming data at scale, then you'd have to use another complementary library called Storm. Then, you decide you want to try to get rid of some of the cruft around the MapReduce boilerplate, so you might turn to Scalding. Or you may find it easier to query your data using something like Hive. And the list of specializations needed to work through an entire Hadoop workflow goes on and on and on. So, along came Spark's generalized abstractions for big data computing, bringing the big data pipeline back to one cohesive unit, just as the smartphone in the original example. Spark's aim is to be a unified platform for big data, an SDK for the many different means of processing. And it all originates from the core library, which means any of its extension libraries automatically gain from improvements to the core, including performance boosts. And due to the core being so generalized, extending it is fairly simple and straightforward. If you want to query your data, just use Spark's SQL library. If you want to stream, there's a streaming library to help you out. Even machine learning is made more straightforward with MLlib. And GraphX does the same for graph computation. On top of all that, the Spark contributors have even brought some of these concepts together using the newer DataFrames/Datasets API, continuing to unify the ecosphere. The course will cover this entire Spark ecosphere with its deepest focus being on the core library, which is what all the other libraries extend, only adding to it where their specialization specifically deviates. And, as previously mentioned, my follow-on course to this one, handling fast data with Apache Spark SQL and streaming, expands the basics of the most important libraries, SQL and streaming.